In today's episode of Humans of Reliability, we are diving into the evolution of DevOps and platform engineering with Justin Reock, Deputy CTO at DX. Justin is an expert in developer experience, productivity, and reliability. We'll explore how platform engineering is reshaping reliability, the hidden danger of productivity metrics, and why developer experience is key to high-performing teams. Justin also shares insight on AI real impact on developer productivity, how engineering teams should measure success, and why trust and collaboration are the true driver of innovation. Let's get started. So Justin, can you tell us how platform engineering really reshaped reliability practices?
Yeah, I think that, it's interesting because it's not like platform engineering was the first discipline to try to approach this problem, right? I think, you saw in DevOps automation put behind things like quality testing and stuff like that. So we learned that the more we could kind of take the human out of the loop and put automation behind the testing and things like that, that we ended up with higher quality software. And I mean, I think that that's just very natural. They say like doctors are the worst patients. And I think in a lot of the same ways, like developers are the worst testers, because you just kind of come in with these preconceived notions. But I think that what then, automating a lot of that stuff away has done, and then kind of converging now on platform engineering as opposed to DevOps, is just that we have a broader view of like the kind of the full feedback loop, right? We have hopefully a more unified platform with less fragmentation in it. And so we're able to collect quality metrics post-release. Right, we're able to really integrate those metrics into the decision making that we make behind our own code quality practices, and I think it's easier to kind of keep people accountable that way. I also think that platform engineering, one of the big differences I would say between platform engineering and something like DevOps is that there is more focus on the individual developer experience in platform. I think that a fair critic, and I'm a huge fan of DevOps practices, don't get me wrong, but I think that a huge and fair criticism of DevOps is that there hasn't been enough dev in the DevOps, right? So when we're able to try to sort of tailor whatever we're doing around quality and reliability to not just shift it all left and pile everything on the dev, but really try to more fairly distribute, where the quality checks are and where the quality work is done, you end up with better adherence to those standards and less, engineers sort of maybe trying to skirt around it or sort of do the bare minimum. So I think it's from a number of places. Like we just have better observability than we had before as part of platform engineering practice, which allows us to be more rigorous in the way that we collect quality data. But at the same time, it's easier for an engineering organization to stick to those practices because we have a better focus on their satisfaction and their overall experience.
Right, like a core pillar platform engineering is to serve, right? I think that's a verb that's usually used in the key principle of this methodology. Regarding like going back to individual and maybe like productivity, which is something that companies are looking to always improve and increase. Can this productivity metric enhance or hinder the system reliability?
I think that, well, and let's be really careful because, and we'll kind of revisit this theme, right? There are productivity metrics, which is just data, right? And we can capture this data, and hopefully we're looking at multiple sources of data. Hopefully we're looking at, different variables, but it can make things better, and it can also make things worse if we're not looking at the right metrics and if we're not integrating the metrics with decision making in a way that benefits and optimizes the business. So I think that when we're doing a good job, I think that when we're using metrics to identify sources of friction in the overall developer experience, when we're using metrics to try to identify and then hopefully eliminate bottlenecks in the process, that naturally you end up with developers who are less cognitively fatigued, right? And we can talk about the relationship between developer experience and fatigue. And as a result of that, you simply have an engineering organization that's got a higher capacity for innovation, but also just a higher capacity to write better code, right? I mean, I think that when we remove sources of toil, and repetitive work, and we are able to shift cognitive load back to where developers really want to be, which is solving new problems for the business, then we're not rushing as much, right? We're not chasing deadlines as much. We're a little bit more free to write the code the way that we would want to write the code. So when we're doing this well, when we're looking at the right set of metrics, and when we're correlating those metrics across things like, for instance, space framework, and doing a good job of balancing those metrics across those different dimensions, then we just end up with a team that's able to flow better. It has easier throughput and just lower friction and lower barriers to overall reliability. We can also start looking at metrics that are specifically about the platform reliability. We have change failure rate is a very popular DORA metric that lets us know how often when we touch the system, are we actually improving the system in the intended way, or are we causing failures that need to have the code backed out? Now, there's this single indicator for that, saying, okay, well, quality is what it is right now. But again, these metrics should be used to inform decisions. So if we see a failure rate that's beginning to creep up, it's on the engineering leadership to go back and say, okay, what's happening here? Like why are we breaking things? What is it? Is it something that we're missing in our testing? Do we not have enough code coverage? I mean, it could be a million things that's causing it. That's how these metrics work. They're really at core, they're distillations of lots of different things. But we can use that to then try to improve that metric to improve our overall quality. We can do this across the board too, readiness assessments. It's something that we all kind of have to face, is this service ready to go to production? But when we have metrics that are more comprehensive, that are looking at the entire service and that are continuously monitored, we don't have to have a human discussion of okay, I checked this box, I checked this box, I checked this box. Instead, we can have that service continuously monitored, so we know, is our code quality where it needs to be? And from our code quality scanners, do we have code coverage at the level that we need to for this service? Do we have on-call assigned, right? And does that on-call, is there continuity there, right? Do we have somebody assigned that left the company 3 months ago, or do we actually have a resource that exists that's assigned to this, right? So these metrics can really help in terms of even before releasing service to production, letting us know that service is truly ready and that doesn't have a high likelihood of causing problems when we release it. Now, they can also hinder us when these metrics are used improperly. For instance, let's say that you were only sort of judging a team by something like a single metric like PR throughput, which can be a useful metric. How often are pull requests being created, being accepted, so that we can move changes into the product. That's an important metric. But if we're interpreting that metric at the individual level, and we start using that metric to stack rank developers, and let's say we use that as a measure of a single developer's performance, and we find out, okay, we have these low performing developers based on this metric, and we get rid of those developers. A lot of times those engineers were the resources that were enforcing higher quality, right? They may not be as active in terms of putting in pull requests, but maybe they're providing a lot of mentorship, a lot of support, that kind of thing. So then you let that resource go, and the team's output quality will decline, which basically means that the reliability of these services will decline, right? So it can hurt us when we misinterpret the metrics or when we get an incomplete picture of what the metrics are telling us.
Right. And if this engineer understand how these metrics are working, and that will impact their job security or bonus performance, they might be tempted to game the system and just do what the metrics want them to do. And as you said, basically it might lose for the organization. So now, if we take a step back, we spoke about DevOps, and there are good principles, but perhaps some stuff are missing. Could you share a little bit more with the audience what's missing from traditional DevOps and SRE conversation?
Yeah, I think that I can answer that by kind of showing what platform engineering has that DevOps doesn't necessarily have, right? The goal of DevOps is rooted in productivity theory that goes back to this, 50s, 60s, and 70s. The reason that the Phoenix Project was so successful as a book was because it modernized Ellie Goldratt's theory of constraints, which was originally used to make predictions about the performance of a manufacturing-based company. And the theory of constraints tells us that we can really boil all complex machinery, even the complex machinery of a business, down to three basic parts, right? Inventory, which in our case is going to be code, right? And code inventory. Cost, which is just that. It's how much does it cost to put these engineers to actually assemble, in this case, code into a shippable product. And then the rate at which we're shipping product is called our throughput, right? And what that really means is making money, right? I mean, if we're a business and we're a code-based business, the point of our machine is to make money. So DevOps kind of took this notion and said, okay, well, what we really need to do if inventory doesn't do anything for the business until we've converted it to shippable code that makes money, is that we really need to decrease the distance between developer hands on keyboards and actually getting code out to production, making money, right? And that's why we learned about, like small iterative releases and just kind of continuous improvement. Like all of these notions in DevOps came out of this early productivity theory. And that's great. That is very good. Like we should be more focused on throughput than anything else. And that throughput is really a distillation of lots of things, like how much friction is in the business, how many bottlenecks and stuff like that. But it's still not the full story, right? That's very much focused on speed, velocity, various activity. But it's not telling us very much about the part of the value stream that's locked inside the head of the developer, right? So whereas DevOps comes from a philosophy that's like a factory floor type of philosophy, it is different when you have highly opinionated knowledge workers that are building the product, right? You have to consider what's going on inside of their head as part of the overall value stream, right? So what does that really mean? It really means that we have to focus more on developer experience, right? That developer experience needs to be considered part of the overall value stream, because it can you can start creating bottlenecks that are happening right up here, right? When we're fatiguing our developers, they can't innovate as well as they normally could. And ultimately, they're not going to thrive as well, right? So I think one of the first things that platform engineering did to augment DevOps was to add a focus on developer experience, right? And the way that you enforce that is by another discipline that I think is part of platform engineering more than it's DevOps, and that's product management, right? So I think in many ways, it is beneficial to think about the platform and to give the same rigor and dedication and feedback and work to the platform as you would for the product that you're shipping, treating your developers as customers, listening to them, getting feedback from them about how the platform is working, how they're feeling about their own work, right? These were elements that were missing from traditional DevOps, which is ironic because it has the word dev in it, but it's really been more focused on the ops side of things. So these things have now come to sort of complement DevOps practices. They haven't subsumed them. I'm getting really tired of hearing like DevOps is dead, because it's not at all. Like, it's an essential fundamental part of platform engineering. We've just, like we always do, evolved our thinking in that discipline. So yeah, I would say that what DevOps was missing was more of a focus on the inner loop and the experience of developers. But I'm very pleased to see now that we have a lot of very positive, I would say, results of making these types of investments. And we're starting to really understand as an industry that this is a huge area of opportunity to improve throughput for businesses. It's not new. You can go back and you can look at the book Peopleware, which everyone should look at. Last edition came out in 2013, I want to say, but it's still very relevant. And you can go into this whole study, but what they effectively found was that when they ran these experiments, which is effectively just giving a developer like a business case and then just telling them to code it and keep track of how long it took them to do it, they found out that like inside a single organization, developers were performing roughly 20%, within a margin from other developers. But what they also found was that there were organizations that were performing 11 times better from a productivity perspective than the lowest performing organizations. And then when they looked at the differences, they started trying to figure out like, what are the factors that are causing this? It's not what you would think. Like, it wasn't language, it wasn't the programming language, with the exception of assembly. Assembly was definitely slower, but the greater generation languages, newer generation languages, it was pretty much the same. It wasn't even really experience. You had folks 2 to 10 years of experience were performing within, again, the same sort of margin with one another. But it was things like the amount of office space that was available to engineers, whether they were allowed to divert their phone calls, whether they felt that people were interrupting them. So it really, even back then, we kind of started to realize, well, wow, the way that you really turn up the dial for productivity is through investing in a better developer experience. It's taken that long, I think, for the industry to really start to believe that, and then make the investments that it is starting to make in that area.
And what's interesting is that the software industry is fairly young. If you compare this to, let's say, the manufacturing industry, which had time to develop all these principles and methodologies to be efficient. And I think we as humans like to look at what's been done successfully and kind of adapt it and port it. And you describe this with the DevOps methodology. And as you mentioned, it brought great concepts. But we are just, as an industry, becoming more sophisticated and coming with this new principle, which ultimately are more tailored to what we are trying to achieve. As you say, it's not like the past one are invalid, they are just perhaps incomplete, and platform engineering is just a step up. So speaking of this, how do you believe platform engineering is bridging the gap between development and operation?
I think that, DevOps was the first attempt to do this. Like, let's take operational concerns and let's try to merge that within the same groups that developers are working in for the purpose of transparency and better collaboration. But I think what happened is that it actually, in many ways, it drove an even deeper wedge, depending on the culture. Because what would end up happening is that a lot of the work just shifted left, right? Everybody loves to say shift left. So now all of a sudden we're expecting developers to learn Kubernetes, and they don't necessarily want to learn Kubernetes, right? They want to keep coding. And so I think that it's actually in some ways built some resentment, where you then have these developers who are like, oh gosh, now we just have to do everything around here, which is probably not true. I'm not trying to disparage or say that operations folks weren't busy. They certainly were. They're busy learning cloud and these new container technologies and things like that. I mean, there was a lot of disruption and upheaval happening on that side too. But I think that in many ways, because of this, not so much of a feeling of shared responsibility, that you have developers who feel like the DevOps revolution has actually just made things harder for developers. But then going back to what I said before about having some awareness around that and actually trying to improve the situation for developers. If we go back to the third tier of platform engineering around product management, well, now our operations teams and the folks who are responsible for actually building the platform have to cater to the developers if we're paying attention to this and doing it the right way. They need to be listening to their feedback. They need to be taking it seriously and then using that to inform next iterations of the platform. So there's a natural collaboration that needs to happen. And the operations teams are suddenly stewards of developer experience. And so there is a shared responsibility, which increases the overall, I would say, sort of psychological safety of developers in that organization, because now they don't feel like they need to fight against their operations teams. Now we don't feel like we need to, I'm just going to code this, but then it's just going to go break when they try to release it. Which is a real mentality. I mean, I come from 90s development when there really was a huge schism there, and there was a lot of fighting between quality teams and production teams and developers because of finger pointing, right? The code doesn't work in production, and the operations folks blame developers, and the developers blame the operations folks, right? And there's not that team sense. It really felt more like there was that there's an adversarial relationship between these groups. And I think that that's starting to come down when you have teams that are really, really good at building great platforms like Netflix, DoorDash, Grubhub, Airbnb. I mean, these are all companies that are LinkedIn. These are all companies that are known for making really good investments in their platform. But LinkedIn also released the LinkedIn Developer Productivity and Happiness Framework, right? And it's not necessarily developers that contributed to that framework. It was platform engineers, right? So I think now that we can do this, that we can really show not just a shared responsibility, but even a stewardship of developer experience coming from what would traditionally be thought of as operations, we're starting to get real collaboration. We're starting to get real trust and real, I would say, sort of mutual respect on both sides of those disciplines.
I think a lot of these methodologies are obviously taken by vendors who want to sell their tools, and for good reason, obviously. But a lot of the time, as you said, it's more about helping humans to collaborate and prevent these frictions between teams. So if we dive a little bit into this topic, do you have like some framework that you believe a team should adapt to be better at collaborating and ultimately increase efficiency?
Well, of course, I'm biased. Coming from DX, we have our core 4 metrics, and I would really encourage everyone to look into these. They are things that you can measure, by the way, without the platform. Like, obviously, we want you to use the platform, but we have made our survey questions public, our survey methodology, and in a way that's consumable, so that if you wanted to run your own surveys and sort of capture some of those metrics, you could. But here's what I will say in terms of just general advice, is that we need to move beyond DORA. DORA metrics are excellent at telling part of the story, right? And they really are an excellent set of metrics. I mean, let's be really clear here. Like, deployment frequency is a very intelligent metric, because even though it's just one number, saying, oh, we're able to deploy 10 times a day, or we're able to deploy 1 time a month, or whatever that is, think about the story that tells about the health of that engineering team. If you're on a team and you truly cannot reliably release more than, like, say, once a month, that is fundamentally a different engineering team than the type of team that could release 100 times a day if they wanted to. Now, you probably don't need to release 100 times a day. But the fact is, you may find yourself in a situation where, let's say, a highly exploitable and well-published vulnerability is released, and your software is impacted by that. If you can't update your software for a month to go deal with that security vulnerability, you're in real trouble. You've now made yourself a big target for bad actors. But if you have the type of health in your engineering system that allows you to release 100 times a day, you may not be releasing 100 times a day, but it means you could release in a minute if you needed to, right? To make that patch happen, right? So none of this is to disparage the DORA metrics. I think they're incredible. I think they're really important, but they still only tell part of the story. And that's where Space Framework actually came from. So the researchers, University of Victoria, Margaret Ann Story, and Brian Hook, and that whole research team, they realized that they were missing parts of the picture just looking at DORA. And so the Space Framework is something that people should look into. It's an excellent way of framing and thinking about how you should balance your concerns in your engineering team. So SPACE is an acronym: satisfaction, which is what it sounds like. How joyful are developers? Are they thriving? Are they happy with their day-to-day work from the perspective of the systems that they're interacting with? Then you have performance, and those are, how often are we having to roll back changes? How often are we meeting our deadlines? How often are we, meeting the right number of story points in our sprints or whatever? So that's another series of important metrics. Activity. This is like just raw activity, pull requests, commits, code being diffs and code being pushed into the system. Collaboration. How well are teams able to work together? And this, extending into things like documentation and code review and all that. And then efficiency. From a perspective of are we doing what we say that we're going to be able to do with this platform? So this is a good step, because one of the fundamental parts of understanding how Space Framework works is that it's not about tracking any single metric. Space doesn't prescribe any metrics. It only prescribes these dimensions. And then it allows you to normalize into that framework. So one study that was done, for instance, was just, hey, go write a paragraph about how you view productivity in the organization. And they ran this study across a number of companies back in April of 2022. But the way that you would then analyze that data is you take every sentence or sentiment that was written as a result of this and you categorize it. Okay, was this a statement about satisfaction? Was this a statement about collaboration? And what you want to see is a balance across all 5 of those dimensions. because it's not about the one dimension, it's about how they affect each other. So like a textbook example would have to do with, let's say that satisfaction is low. Let's say we run a survey, we find out the developers are angry about this approval gate that they have to go through. They feel like it slows them down. So we're like, okay, cool. Well, we want to improve satisfaction, so let's just get that gate out of there. Well, that's not the end of the story, right? You have to then continue to look at the metrics and say, okay, well, we got rid of that approval gate, but did that hurt our performance or did that hurt our efficiency? Because it turns out that gate was actually important, right? So now we're getting closer. Right now, we're getting to a better framework. Then DevX came along with it. The DX published, along with Microsoft, some other folks, the DevX metrics, and these focused on developer experience. And these are things like cognitive load, flow state, feedback loops. Right. So now we're starting to get into that developer's day-to-day experience, and we can use those metrics to feed back into things like satisfaction and like activity. I really would encourage people to look beyond DORA. First of all, make sure that if you're doing DORA, that you're actually doing stuff with that data, right? We definitely run across a lot of folks who are like, yeah, we put DORA in, and now what? So we got this data. What are we supposed to do with it? So really make sure that you're maximizing the potential for that data by building it into your decision-making processes, right? Don't just, stab around as to whether or not you think you should invest in better quality. Look at your change failure rate. Is it bad? Is it bad compared to, other companies in the industry? And if it is, okay, well, then you should go make some investments and improve reliability and quality. But maybe it's not. Maybe you're fine. Maybe your real problem is that it takes too long to get changed into the system, right? Okay, well, then let's make investments on better documentation, better onboarding, whatever that is, right? But to take a use case driven approach. So first of all, if you're doing DORA, make sure you're doing it right. But then I would also encourage you to sort of remember that DORA is 10 years old at this point. And we have continued to evolve our theory, just like we've moved from DevOps to platform engineering. Our sets of metrics have widened and have become more effective. Now, the DX Core 4, which is the metric framework that we recommend, is a distillation of all three of these, right? So we took some of the best metrics from DORA. We took the philosophy of space framework in terms of trying to balance metrics across these important dimensions and understand how they impact one another, and then integrated the DevX metrics as well. Because, on their own, they're all excellent metric sets. And if you use them properly, you will be successful in what you're trying to improve. But they're not as portable as the Core 4 is, right? Going back to one single set of metrics. So I am biased, but I really think that the Core 4 is something that can benefit every engineering team. Especially when you think about, when you decompose it a little bit and look at how it's sort of the culmination of these evolved metric sets that have been happening since DORA.
So speaking of metrics, the hottest topic now is GenAI. DX is really the leader here in this type of metrics. Like, did you find anything interesting like that the industry should be looking at?
Absolutely. So to kind of add a little bit more color there, we've built into our platform something that we call our GenAI Impact Report. And this is based on both qualitative survey data that we gather from engineers who are using AI copilots. And then if you're using GitHub's Copilot, we are pulling in system metrics coming from the Copilot API. So these are things like number of code suggestions that were put in front of an engineer versus how many of them were actually accepted. And then we can correlate that. So specifically with GenAI, I think one thing to realize is that the time savings is not the most important metric. And this is where I really like DX's approach to this. If you look at how we've positioned it, yes, we have a dashboard that shows you roughly how much time and therefore engineering dollars have been saved. And it tries to estimate that based on these metrics that we get out of Copilot as well as our survey data. But what's more important is that we correlate those time savings we correlate that usage and time savings to other metrics within the platform. So for instance, one of my favorite things to look at in this part of the platform is time allocation, right? So part of the survey data says, how often are you working on new things, new features, and new improvements versus more maintenance and keeping the lights on type of work, answering tickets and that sort of thing, versus other stuff like meetings or whatever. What you really want to see is, for instance, a higher utilization and time savings from AI resulting in a larger allocation of time from engineers spent working on new features, right? I think like we have this sort of misconception that in order to help developers have a better experience, that we need to reduce their cognitive load. Like I see that written in a lot of places, reduce cognitive load, I think that's wrong, right? Because if you look at like flow state, and if you really look at the neuroscience behind flow state, and not just for engineers, we find that like jazz musicians, for instance, improv jazz musicians are being studied right now because they can almost immediately go into a flow state when they start playing. And that's because we've learned that flow state is caused by shuffling long-term data that's stored in the back of the brain into the prefrontal cortex, where you can actually then use it to control your movements and what you're doing, right? So a flow state is caused by a rapid shuffling of long-term storage in the back of the brain to actionable parts in the front part of the brain. And that releases all this norepinephrine, serotonin, dopamine, all these neurotransmitter chemicals that put us in this great state of flow. That's not happening in a reduced state of cognitive load. That's happening in a very high state of cognitive load. The difference is that it's interesting, right? It's work that the brain naturally wants to focus on to bring you into this state. So this is such an important metric to be able to say, we have now shifted the cognitive load of our engineers to work on new problems, unsolved problems for the business, right? To work on new things that'll innovate and drive the product forward. So that's how DX has taken this approach. And I think it's the right approach. It's not, don't just track the time savings, because what's the point of the time savings? I mean, if you're saving the developer a couple of hours a day and they're just using it to scroll social media, like the outcome to the business hasn't really changed, right? And you have to start asking yourself questions too, like how much of developers' time is actually writing code, right? I mean, like, is that currently the biggest bottleneck? Or is it, that they're spending more time searching for things or trying to find the owner of some dependency to go and talk to them and get the information that they need to do their job, right? So just looking at time saving alone, or even I would say reduce cost, doesn't really tell us the outcome picture. The other thing that I would say is interesting too is that when we start looking at these savings, we see them very clearly at like the individual level, and to some degree, even at the team level. But when we start looking at the organizational level, we're often not seeing like significant output at that very top level, right? So it's like individual engineers and even teams say, oh yeah, this is basically saving me time. But then when you look at what's getting delivered, it doesn't move the needle all that much. And I think it's because of these other aspects that we're talking about, that it's like just saving developers a few clicks on their keyboard is not really attacking the primary bottleneck, right? So that's been an interesting trend as well. I still think that these things are valuable. I mean, I think that, for no other reason than for developers to be able to have sort of like a research assistant, that's going to make things a little bit more smooth for them. I do think that there's value, but I think the jury is out as to whether this is actually helping software companies deliver software faster.
Fascinating. So actually, Justin told me off the record that they are working on a report. So stay tuned. I'm also looking forward reading the findings, because that sounds like extremely interesting to see how GenAI
that'll be a lot of what we're
actually impacting an organization. So we're
going to slice and dice the data pretty well. You'll be looking at where it's effective, but I'm excited about this report. We're also going to be kind of breaking it down by demographic, so you'll be able to get a look at like, is there a particular programming language where the Copilot is more or less effective? Is there a seniority level? Like, are junior engineers tending to get more benefit out of this, or senior engineers? Because there's a lot of speculation in this area, but we haven't provided a ton of data. So thank you for bringing that up. I'm excited about putting this report out there.
So we spoke, DX is like really the leading player in the developer experience space. For our listeners that are getting started here, if there is one metric that you believe every engineering team should track, which one would it be?
This one was hard to answer, and especially because what we preach and what the truth is that you shouldn't just track one metric. There's lots of metrics, and you need to look at the way that they affect one another. But when I really think about that distillation, which is, I think, when you've really got a powerful metric, it's a metric that tells multiple stories about the health of the team all in one single number. When I really think about that, my first answer was like focus time. Like my first answer was like, okay, how often are we just letting engineers do their job and not pull them off into other work? And I was almost landed on that. Like that's what everybody should be measuring, and we should all be sure that we're really aware of giving our engineers this time. And it's true. But I think what is even one level higher than that is the metric that I mentioned earlier, the time allocation, the time spent on things in the organization. I think that is so powerful to get an idea because it tells us multiple things. It tells us how unmaintainable is our code base. How often are we breaking things? Because generally, if developers are working on answering tickets, keeping the lights on, that sort of stuff, that's too much maintenance. Like the code base requires too much maintenance. So we should be looking at that. If developers are not spending time on interesting work, then we can predict a lot of their overall satisfaction, right? I mean, it's pretty easy to say like developer joy equals developer productivity, right? I mean, we got into this field because we like coding and we like solving problems. Like these are the things that our brain wants to do. But if we're in a culture or subject to a system that doesn't allow us to spend that much time on interesting coding work, we're not going to be satisfied. We will not be joyful in our work, right? So like people try to separate these things, but I think that they're very much linked. I think productive developers are happy developers and happy developers are productive developers. So I think if I really had my desert island metric, like I think it would be the allocation metric. Like how much are we really allowing our developers to work on new, interesting work? There's economics to that too, obviously. Hopefully our product is lucrative. I mean, if we're losing money on our product, I can't help you. But if we're shipping new features and that means more money for the business, then allowing our developer team to spend more time on these new features and crank out new stuff that we're going to be able to upcharge for or get more customers or make customers more sticky, then there's a really good economic behind that as well, beyond just getting a warm, fuzzy feeling from our developers. It's really the best of both worlds. So this was a hard question because there's a lot of great metrics and we all should be tracking, dozens of them, not any just one. But I think that this one metric of time allocation tells us so many things about the business and about its health, about the satisfaction of our developers, and about the economics.
Justin, if people want to get in touch with you online, where can they find you?
I'm pretty easy to find on LinkedIn. You can also probably find, at this point, I think dozens, maybe even hundreds of talks on YouTube that I've given, other podcast episodes and stuff. I'm very, very passionate about this subject. I will talk about developer experience all day, any day with anybody. So please feel free to reach out. I hope you will. But yeah, I'm very easy to find on LinkedIn. That's where I do most of my community collaboration.
Great. Justin, thank you for coming on the show.
Oh, it's my pleasure. Thank you.